All right, guys, Rowdy Yates with High Plains Biochar. We've got Ryan Thompson with Mountain Air Engineering today, and we want to talk a little bit about emission testing. I know this has been kind of a big buzzword in the biochar world. Everybody's trying to figure out how to keep the most clean emissions they can from their biochar equipment. Today, speaking of equipment, we are sitting here in front of the Continutiki. So right now we are running a little over 500 C on the temperature-wise, but this is one of our new systems that we've designed. It has a lot of upgrades over a traditional Continutiki. For one, we're able to collect our data, operational data as far as carbon credits. We've got a nice auger system here for unloading, which means a lot less labor involved. We've got a quench system, so we add water while we're unloading through the auger, which allows us to use a lot less water during the quenching process. And we've enclosed the whole operation, so it makes the emissions, we were able to reduce the emissions, we're able to increase our heat, and also makes it a lot safer so we can operate on days that are windy, where we don't have to worry about embers and sparks flying out of our stove like a normal flame cap kiln does. But it's also safer for the operator, a lot less emissions that they're breathing, because this has a stack on it, so the smoke is actually being exited up in the air as opposed to right in their face. And it's also just a lot less labor intensive, where instead of having to shovel biochar out of a hole when you're unloading here, we just press a button and it unloads into the barrel. But the real focus of today, we want to talk a lot about the emissions that we're testing right now, and I want to let Ryan kind of tell you guys a little bit about what we're doing, and then we're going to spin around to the back and let him kind of go into some detail about some of the equipment that he uses and things that he's looking for when he does this type of emission testing.
Yeah, so we have a portable sampling system here. We're using to measure the emissions, and we're taking a sample out of the chimney. And so we're collecting filter samples of the particulate matter, and we're measuring gases: carbon monoxide, carbon dioxide, methane, NO, nitric oxide, nitrogen dioxide, and volatile organic compounds.
Perfect. So now we're going to spin you guys around and we'll show you a little bit about how this works.
Okay, so this is the Possum 1 portable sampling system. This is what we're using to measure the emissions. So this is a sensor box that has all the sensors in it that's measuring the emissions. And then all the data is being logged on board, and it's also being sent to the computer. So we can have a program here to look at the data in real time. So we have a list of all the sensor readouts, and then we also have a plot that shows the concentrations. And right now we're plotting carbon monoxide and carbon dioxide and particulate matter in the plot. And so coming around to see how the sensor box works. So all the sample lines are coming in here. We have an undiluted sample line that's coming straight from the probe. It goes into a water trap, and then to a HEPA filter, and then to a desiccator to dry the sample before it goes into the instrument. And then we have these diluted lines also. So we have the sample that goes into the particulate matter sensor, and there's two filters. And then we also have the dilution air that's being pushed out to the probe to mix with the sample. And then down at the bottom, we have these two pressure lines that are measuring the differential pressure from the pitot tube, and a thermocouple to measure the temperature in the stack. And so if we look up here at the probe, what's happening is we have the dilution air going up this line. It's hard to see because we have the foil in the way, but this probe was kind of designed for an insulated chimney, and this chimney is not insulated, so we had to add a heat shield to keep things cool. But the dilution line goes up and mixes with the sample, and then the diluted sample comes down the other line. It goes through the PM 2.5 particle separator, and then it splits, and one sample goes to this filter, one sample goes to this filter, and then a third sample line comes down to go to the gas sensors. So one filter is gravimetric to measure the PM mass. The other filter is a quartz filter to measure the particle composition. And then the undiluted sample line here comes out to go straight into the instrument. And so here's the sensor box on the batteries it's running off of. Here's the tricolor absorption photometer that measures the particle light absorption of the smoke. And then we have these valves here adjust the flows so we can set the system flows for a particular sampling application. Okay, so then we also have we're also collecting a Tedler bag sample. So down there we have a pump and a flow control system that's slowly filling this bag over the course of the test. And then we'll take this bag to the lab and have it analyzed in the gas chromatograph for methane.
Okay guys, now that you've learned a little bit about the emission testing that we're doing from Ryan, now we're at the final stage here. We're gonna go ahead and unload the biochar. So if you kind of come in here and look, you can see that the fire is just about turned out. I think our temperature, we're at about 600 C, but we're just about wrapped. You guys can come around here and you can see the fire's just about out in here, not much going on. So we're gonna go ahead and wrap this up. So what I've got here, I've got my 2 buckets of water. I've dropped my pump in there. So I'm going to go ahead and kick on my auger and kick on my pump so that we have some water to quench the biochar with. I'm going to go ahead and kick on my vibrator to keep the material flowing through the auger, and then I'm going to go ahead and kick on my pump. But here we go. This is the unloading process.